Hello, good afternoon, and Assalamu alaikum. I would like to welcome you all to our fourth AITS Tech Talk webinar. Today's session will be about the AVEVA Communication Drivers Part 2, where we will cover the IIoT, OPC UA, web services, MQTT, and telemetry servers such the MP3, Modbus, and IEC 6870. Before we start, I would like to gently ask everyone to stay muted during the session. And in case you have any question, remarks, you want to leave a note, please feel free to leave it in the chat area. And we will be answering all your questions at the end of the session. My colleagues Munzer Karhani and Janine Kuta will take us through the webinar content. So I will leave you in safe hands with Munzer first. Hi, Munzer.
Hello, Nader. Thank you so much for your introduction. Hello, everyone. As introduced by Nader, today we'll talk about, it will be the second part of IIoT, about AVEVA communication driver. We'll talk about IIoT and telemetry drivers. So we'll go walk through the drivers that we have, and a small demonstration how to configure every driver by itself. Now, regarding the telemetry, we decided to make a separate session later on because we find it's need a separate session by itself. So we are preparing a session, like it will be more than 30 minutes, just about telemetry server in the future. Today we will make some fast briefing about what is IIoT for the people who doesn't know, because IoT came recently, or it's not an old concept in the industrial field, but it's an old concept in the IT field. So what is IIoT? Then we'll talk about some drivers that works in IIoT, like OPC UA, web service, and MQTT. At the end, we will give some overview about the telemetry server. So what is IIoT? IIoT, or industrial part of Internet of Things, or industrial part of IoT. So the IoT is enabled by technologies such as cybersecurity, cloud computing, edge computing, mobile technologies, machine-to-machine, 3D printing, advanced robotics, many fields. Many technologies are enabled by IoT, or enabled IoT. And this allows to leverage the automation of houses, hospitals, airports, parking, smart cities, and many others industry like oil and gas and power. The industrial Internet of Things, or IIoT, refer to the interconnect smart sensors or smart instruments and other smart devices networked together through computers industrial applications, including manufacturing and energy management. This connectivity allow for data collection, data exchange, and analysis, potential facilitating improvement in productivity and efficiency, as well as other economic benefits. The IIoT is an evolution of a distributed control system that allows for higher degree of automation by using cloud computing to refine and optimize the process control. So how it's the infrastructure of IIoT? It's as simple as this. You have sensors, as I said, actuators, equipment, and edge nodes. All of them are connected through something we call it IoT gateway or edge gateway. Those IoT gateways are the gateways to our platform or on-premise server, on the cloud, etc. And behind that, there is the data process, historian, SCADA, etc., business application that are communicated to these platforms. Today's session is to focus about the IoT gateway edge and the edge gateway. So we will talk about several drivers, such OPC UA, the web service, the MQTT. And there is another one we will not cover today, which is SNMP, which is a driver for network components. But it's not covered for today, just mentioning that it's part of the AVEVA communication drivers. It's already there. So how to find these drivers? As simple as to go and register to software support sp.aveva.com, and you will find a tab that's named Connectivity Hub, where you can find all these drivers. Now, we can start with the OPC UA. What is OPC UA, or simply OPC Unified Architecture? It's released in 2008. It's a platform-independent, service-oriented architecture that integrates all the functionality of the individual OPC classics, like DA specification. It includes all these specification into one extensible framework. This is a multiple layer that's allow the approach accomplish the original design specification goals of like functional equivalence, platform independence. That means we can communicate. OPC DA or the OPC Classic is a Windows product, so but OPC UA can have a communication between Apple, Linux, and Windows, different platforms. It increased the security. You can make some encryption, authentications, and auditing. There is other more feature extensible. So ability to add in, you have the ability to add in new features without affecting existing application. And it have a comprehensive information modeling for defining a complex information. Plus OPC UA is very good between different platforms. So for example, you have two different platforms, two different OPC. OPC UA mostly use something called bridging or tunneling. You can bridge between two different systems. So enough talking, and we can go straight away to our application and explain what is OPC UA. Just let me minimize. So in my demo, I will use a Kepware OPC as a server. So in Kepware, I have already a simulator, a data simulator. This is what I will use between the function, and I want to read this function. It's a float random function. But before that, I have to go here and on their properties, make sure that if I go for things, cancel activity, here options. Okay, fine. That's all. Okay, I have to configure my OPC or give the configuration of my OPC. So I'll go right click OPC configuration. This is all related to the OPC server. And I have two links for my OPC server. I will use the second one. I can add or create or whatever I can do here. It's again all dependent on the OPC server itself. In my case, I will use this link, and I will choose what types of security I want to use. In my case, I will use without any security. And this link, copy. This link, I will use it in my driver. That's it, and close. Now I have to prepare my driver. In my SMC, go for Operation Integration Server Manager, local, Operation Integration. Let me open it here. I'll go for Gateway, OI Gateway, Configuration. And here I have OPC, but this OPC is OPC DA, and I will create my own OPC UA connection. So first I will name it OPC, you can name it whatever you want, UA. So what is that server host? Where is my OPC server? It's my local host, OPC server, past. I'll go for advanced. Everything here is related to the OPC server. So am I allowed for an anonymous user? Yeah, I already configured my OPC server as anonymous user. If you have a username and password, you have to put it here to give authentications. You can use whatever security model, etc., etc. In my case, I will use no security model without any user credentials. Test. Inheritance, it's fine. This is my my node. It's ready. Now I have to prepare the group. So let's save it. Right click and add OPC group. I will name it device group. Enter. And there you see the device group name is automatically generated. This is the one that we will use inside Orchestra or inside my system platform. Device name, it's empty now. And there is here MQTT publish item. So OPC UA or OPC UA, both of them have this this field. If we go for device group, here I have something called MQTT publish in OPC DA or OPC UA. This is used in case I'm using MQTT through a third-party OPC. So I want to publish through a third-party OPC. We will go for MQTT publisher, which I already have. I have my own Wonderware driver, so I don't need to use this one because I will use my own driver. But in case I don't have my own driver and I have a third party, I can choose this part. I will not go for this. MQTT will be second part or the last part, the third part with Janine. Go for here. Now I want to collect the data from my OPCs. This is where I go for browse OPC UA. Remember I'm going for RAM2, so I'll go for objects. Remember it's calling simulator examples. This is the topic here, or the channel. This is my channel. So simulator example functions. Go for functions. And you will find a lot of addresses. What I need is RAM2. I don't need the address and the client access or description. We can add many, all of them. But I only need this one as an example. I will add it to my list, RAM2, and OK. Next, in device item, as you see, I have the name and item reference. The item reference is my address from the OPC UA. The name is the name that I want to use inside my system. So I'll use a better friendly name. Let's say I will name it RAM2. Now my driver is ready. Save. Right click and activate. Activate until reboot manual. I prefer it during a demo, but in a real life scenario, it's always automatically reboot, start after reboot. Next, I will go to my system. In here, I already prepared an object called temperature. In my temperature, I put an attribute as process value, PV. This is my attribute, and I want to read the process value is the RAM2. So this is what I want to link. I want to link this attribute to RAM2. So first, let me create a device integration object. This is an empty one, new instance. And I'll name it my OPC UA 1. Double click. As any normal device integration object, same configuration. So what is the server node? In my case, it's local host. Server name. Remember, server name is always, most of the time, what is the between dots. So for this part, I have oi.gateway.2. So my server name is gateway. In case of Modbus, for example, it's MBTCP. Allen Bradley, it's ABCIP. This is Allen Bradley CIP. So what is between the two dots? This is what I want to use as, or I have to use as my server name. So gateway. Topic name. Now here is done. I have to go for topic name. I have to add a topic or a group name. The topic name is supposed to be It's already defined in my system. Group name, device group name. This is my topic name. So copy. Let me add and paste. That's it. Now, because I already used a friendly name, I have to define it here. This is one of the ways. You can use the hierarchical name from the OI server, but I use a friendly name, not a hierarchical name. So I will put it here. So let me add an attribute. What is my attribute that I'm using? I'm using temperature. This object, temperature.pv. And the item reference, just make sure about it, is RAM2. Save and close. Deploy. And in my device, IO device, I have to assign my temperature to my OPC device group. Once it's assigned, deploy. Now let's test it in Object Viewer. I already prepared a watch list for it. Again, it's here. So I'll go for temperature, PV, add to watch. Here it is. That's it about the OPC UA. Next driver will work, or actually it's two drivers. It's two-in-one driver, the web service. The web service, it's actually a service, it's even a service offered by an electronic device or another electronic device, communicating with others through the internet. Or we can refer it as a server running on a computer device, listening for requests and at a particular port over a network. It's serving web documents like HTML, JSON, XML, images, and creating web application service, which server in solving specific domain problem over the web, like the internet, HTTP, or www. And there is two, as I said, the SOAP and REST. As I explained, SOAP is an XML-based message protocol. This is the first difference. So SOAP is Simple Object Access Protocol. Is a message protocol that allows distributed element of an application to an XML message. So REST, or we call it representational state transfer, is an architectural style for providing standards between computer system on the web and making easier for system to communicate with each others. So this is the first definition, and even it's the first difference between them. So what to use, SOAP or REST? There is a big debate between them. For example, SOAP use what we call a WSDL or Web Service Description Language. However, REST use XML and JSON to send and receive data. SOAP invokes services by calling RPC or remote procedure call methods, and REST simply calls service via URL path. SOAP doesn't return human readable results. It's an XML file that has been used, but with a simple JavaScript, we can restruct the result. However, REST is readable, just plain of XML or JSON. The good thing about SOAP, it uses different protocols like HTTP and SMTP, FTP, different protocol, but REST can use only HTTP. JavaScript is easy with REST more than SOAP. And regarding the performance, SOAP needs more resources than REST. So REST is lighter and easier. The infrastructure between those two drivers is, as I said, SOAP from the application to the endpoint. You can use, depending on the endpoints, you can have many applications like calculation, add, divide, subtract on the website. However, the rest you can have, it's all HTTP, so you get post, put, or delete data. In our application, SOAP and REST must be installed. We can go here, let's see, minimize, and we can show it. So first, OPC UA, it's already included with the IO gateway. However, the web service must be installed separately. It's called Web SVC. This is the name of the driver in our website. And you can find here under the configuration the ports, and we can add even SOAP or REST. Let's start with the SOAP and then continue with the REST. For SOAP, I already have a website prepared. This is the website or the link I want to read and write the SOAP. This is an XML file on the website that I can send data and get a result for add or subtract, multiply, divide, this kind of calculation. It's a test, simple one for free. So I'm adding a SOAP connection. So what is our WSDL? Okay, I will get it as it is. Copy. Paste here. Instant name, I will name it calculator for calculation, and let's connect. Successfully connected. Now here device group, I will add my device group and my item names. So it's empty for now. This way I make a test for 2 here. So 2 plus 2, this is add. I will use the add one test. Let me test out everything. It's here 2 plus 2. I have those tag names. Export to device items. If I go for device item, it's all here. Automatically added. To make sure about it, let me clear all because I already prepared an XML file. One of the import is SOAP because I changed the .a and b, input A, input E to X and Y, and result return. This is the result return. This is the address. It will return the whole XML, and this is the result of X plus Y. So I change a little bit in name. I can change, and I'm using the hierarchical name here. So I have an object named calc and process value X, process value Y. Attribute X, attribute Y. This is what I'm prepared in my system. Next thing here, I have to add a topic name. So the topic name I'm using, I will name it SOAP G, SOAP group. That's it. Here is right, here is right, device name, save. Just I want to change the name of the driver to SOAP. You can put whatever, any name you want. And right click, activate until reboot. Let's go to our system. So I already, as I explained, I already prepared an object named calculator, where I put result, attribute result. So the first one is the integer, add result. It will give me X plus Y. So result is read, X and Y are right. So I'm sending to the link to value. Run. Oh yeah, I forgot something here regarding run. Because I'm reading from the internet, let me go back. The device group here, if I keep it 1000 milliseconds, that means I'm reading every 1 second from the internet. Some people need to have just give me the updates. So I make it 0, and I will read only if I want to read manually. So let me save, deactivate, yes, and reactivate again. Okay. Let's go back to our system. And this is what the run will do. This is from the system as well, .run. It will send the update. So once I change X and Y, give me the result when I click on run. That's it. This is the object. Regarding the device integration object, it's already prepared. It's my PLC. So I prepared actually for both because it has same configuration. Server node 127, server name, web SVC, the topic. So I have SOAP G, this is what I create, and I will create later on the REST G. Save. Already the SOAP, its calc is part of the SOAP, and let's go for object viewer. In object viewer, I already prepared the watch list. So load watch list. Yes, okay. In SOAP, this is my SOAP. This will take pending. Let's just reconnect. Apply. Okay, mixed because SOAP is connected and REST is not even created yet. Okay, so I have to make X, let's say 3, okay, plus Y is 4. Now it's bad because I will go for run, apply. This is a connection. There it is. So 3 plus 4, I'm reading from the link 7 plus, which is important, the XML message. This is what I get from the system, and the add result is here. That's regarding SOAP. Next is REST. REST is a little bit different to configure. Let's make one. So I will add a REST connection. I'll name it REST. And here, when you create any REST communication, it will show you the web service address. This is how supposed to be the syntax. Blah, 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 www.whatever.com, then parameter 1, this is the name, whatever. I have some parameters between the symbol. When I have it, like it will create a parameter to my system to change automatically or change manually, depends on my system here, to change these parameters. What that means, I'll give an example. Here, I already have a website that provides this URL parameters. The website that I will gonna use is current weather. So it's openweathermap.org. When you have to sign in, and once you're signed in, yes, you can. It's for free. There is some for free. Startup is $40 per month, etc. But what are the free options? This is what I need for now. I only need those options. I will go for guide. It will give you all what you need in here. So how to generate the URL. It's here. This is what I want to read the temperature or the weather for every city. So this is the API that is providing me city name. I have to put here the city name and your API key. I will go for this API key. First, I will get this as it is, copy, and put it in my web service. Oops, what I did. Again. Copy. And paste. Something wrong here. Control C and Control V. Okay. So city name. Here we can put any city you want, like London. And the API key, it's provided by the web server itself. So it's already mentioned how to get a API key. It's already here. You can generate, I already generate one for me. Copy. And let me remove your API key. Control V. That's it. Analyze. It's already there. There is no error. Let me test what I have. So right now, those are the value I'm reading from the website. It's London. This is the city name. And the temperature, it's 282. This is in Kelvin. We will convert it later on. However, I want to not be connected to a dynamic city. I want to change the name of the city, many cities. This is why it's called the parameters. Instead of London, I will remove it and I will put city like this. So now I have a parameter called city and I can change it. Test. Those are the tag names and it generates a query. So I can send a query for what city I need. Those are the tag name. As well, if the website can support some struct array key, we can add some struct by the website. I will not add any struct for now. Those are the device items that I need. So let's export it to device items. Once click here, I have the device item ready there. Those are the reference and those are the item name. However, I will not use the item name. I want to change to something more readable from my system. This is why I choose item name as hierarchical name.attribute. Let me clear all. It's already prepared from my part. Import rest. I choose city.city. This is where I put the query. The name, it will give me back the name of the city that I'm using. Run to start the request. Temperature to read the temperature in Kelvin. So I need the run because I will make a device group as rest G group, rest group, and update interval because I don't need to use the internet all the time, just on update 0. Save. So I can update even manually or put run in a script, update every 1 hour or depends on an event. So update on an event. That's it. This is all from here. I'll go to my, so this is my city. Prepare the object. Again, I'm writing the name of the city, reading the name of the city from the system to make sure that this is the city that I'm asking for. Writing a run, it's a Boolean to start the reading. Temp to read the temperature, and temp C, it's in the script, it's internal, to simply convert from Kelvin to Celsius. That's it. From my PLC, it's already put the rest.g. So let me redeploy. Before that, allow me to deactivate and reactivate again. This is what I prefer to do to make sure that the new configuration are taken. Okay. Now let me redeploy my PLC. Go for object viewer. This is the rest part. Make sure just taking is connected. It was mixed. Now it's connected because both topics are there. So city name, This is what, no, city name is read, see, yeah. So the city name, I want to look at the Dubai, the temperature in Dubai. Let's go for run. Now Dubai is 306 Kelvin, 33.5. Yeah, it's a bit hot today and false. Let's see, city name, Mumbai. Wait, apply. So apply. I don't have Mumbai. Okay, it's bad. So the city Mumbai is not out. Maybe it's a typo. Rome. Let's try with Rome. And try another city. This is Rome. Apply. Rome. Rome is 17 degrees. It's nice weather there, etc. And that's it for web service and OPC UA. Now for next, I will give for my colleague Janine. She will continue to work on MQTT, to explain the MQTT part. And in MQTT part, we will after the demo, we will make like a small chatting between my system and her system. Janine, she's in Istanbul, in Turkey. I'm in Dubai, and I'm using a platform, and she's using a totally different platform on a system, totally different system. And we will chat to each other through our servers, our systems. So Janine, I will give you the presentation.
Yeah, hi Munzer, how are you? Thank you, Munzer. Okay guys, how are you? My name is Janine. I'll be presenting today MQTT. So what is MQTT? Actually, MQTT is a protocol, and it stands for Message Queuing Telemetry Transport. It's a publish-subscribe machine-to-machine protocol that is used to transport messages between devices. This protocol is transported via TCP/IP, and it's very ideal for your Internet of Things world of connected devices. It requires very minimal design for your built-in systems and mobile phones applications, with memory and bandwidth sensitive applications as well. Next, I will be talking now here about the major component of the MQTT, which is MQTT broker. So what is an MQTT broker? An MQTT broker acts like a server that receives messages from all clients, filters them, and then reroutes the messages to the appropriate destination clients. The MQTT broker is the center of every publish and subscribe protocol. It acts like a post office. So now, in order to transport those messages through clients, from one client to another, we need a message or like a topic. It's more called like a topic. What is a topic? A topic is a string that the broker uses to filter messages, for each connected client. The topic name, the topic, which is a string, consists of different levels. It can have more than one level. Those levels can be separated by a slash. Now, in our demo, we're going to configure an MQTT broker, and we're going to configure also the topic using the OI gateway, which was first introduced by my friend Munzer. So now let's go to the demo. We keep back. Sorry. So here we have. I have already created a galaxy here. Let me first go to the broker that we're going to use today. The broker that we are going to use today is the Mosquito broker. It's a free broker that It's a commercial broker that everyone can use. In today's session, I'm not going to integrate security. I'm going to use an unencrypted MQTT, and I'll be using the port 1883, okay, to communicate. So this broker is for free. You can use it. In order to get connected to this broker, I'm going to need an OI gateway. So what to do is just go to the SMC. So here's my SMC. I will go to the OI gateway and I will start creating a new configuration here. So I will add an MQTT broker connection. I'm going to call this MQTT. Call it whatever you want. Here, I'm going to specify the network address of the broker, which is here test, which is this one here. So it's test.mosquito.org. I'll just copy that to the address inside the SMC. Okay, paste it here. All right, and then I will validate the connection. Here it's validated. Now, the second step, I need to add a connection to here. Yes, I will save changes. And then I'm going to call this connection G1. You can call it whatever you want. And then I'm going to configure my devices. And it's worth noting here that the device group name, I will be using that inside the IDE, inside my DI object. This one, the topic name here. I will be using it later on. So I will now configure my device items. So I have created inside the IDE an object, which is user-defined object. It's called MQTT_001. It has an attribute that will send data to the broker. It's called send. I will show it to you later. And then this attribute will send data to the broker. It will send it to a topic, because the topic is the message. So I will create a topic here. I will add a topic here, which is called MQTT, and I'm going to use the same, syntax that I just talked about before. I'm going to call it MQTT/send. You can name it whatever you want. It's a UT8 string. And here I'm going to add a new one. It's called MQTT. It's another attribute also configure. It's called receive. And what I'm going to be doing here is that I'm going to send a string to the MQTT/send topic. I'm going to receive it back. So it's like reflecting back to my system. So I'm going to use this one, MQTT/send. Same thing. So I'm sending a message and I'm receiving the same message again. Okay. So here I will save. Okay. So I will save and I will activate my OI gateway. Oh, now it's active. Now I will show you what I've done in the IDE now. Now in the IDE, I have created an object. It's called MQTT_001. And I will double click on that to open it to show you that I have created two attributes, two string attributes. I have the receive and I have the send attribute created here. And how did I create my the device integration? So I will close this. I will go to the gateway here that I've created. And of course, like Munzer said, we need to specify the server node, the server name, which is gateway in my case. And then the topic name will be MQTT_0_T1, which I talked about before. That's it here for my configuration. Now, everything is deployed. And I want to note that I have already assigned my object to this topic. It's already assigned here. All right. So now I will go to the object viewer and I will connect. Okay, now it's connected. Now I will send a message. So hello. Okay, right. Okay. So now what happened here is I'm sending a message and I'm receiving it back. So what's going to happen right now is that Munzer, I'm in Istanbul and Munzer is in Dubai. So what's going to happen right now is that I will send a message to Munzer and he will reply back. Because why? Because we're using the same topic name. So Munzer will do the same configuration as I did and use the same topic, which is MQTT/send. So now I will say, hello, Munzer. I just sent him a hello. So Munzer, can you hear me?
I just received hello. Yeah, I just received it.
Just received the hello. So
yeah.
all right. So I will give the screen to my friend Munzer, and then now Munzer will just send me a message back. Okay. So I will give him the presentation now. Here you go.
Okay, so this is where we are now. For my system, totally different application, different galaxy, different IP, different everything. From my part, I create a session here, a driver called MQTT2, but I must use the same port name. I think Janine, she is already using this port name from mosquitoes. Yes, this is a mosquito she already work on. So they will show different here, test mosquito. Yeah. So we are using this port, which is unencrypted. We're not going for any security. This is the port. This I have to keep it, validate address. It's already there, successful. Then let me go, I change it to GR. So my device group name is MQTT2.gr. Device name, I have an object called MQTT-O. I change the name object, but I have to use the same topic name and the device reference or the item reference. This is from here, going to my system, MQTT object, same configuration, different naming. Same receive. This is I'm receiving. I must receive a hello from Janine, send, where I can, it's right to send to Janine. I already prepared the object viewer, it's here, so I'll send, as you see, Janine. Hi, Janine. Okay, now Janine, could you please send me anything? Hello? Janine?
Yeah, yes, hi Munzer, I'm still here. Okay.
Yeah, could you send any message from your part?
Yeah, sure. I will send you hello there, Munzer. Hello there, Munzer. Okay?
Okay.
All right.
There it is. We are connecting to different platforms, to different places, geographically separated through same broker. Thank you, Janine.
Thank you, Munzer. Thank you, everyone.
Thank you. And that's it about MQTT. Last but not least, the telemetry server. What is a telemetry server? Well, in the words of industry automation, the geographical distributed application is an extension of traditional plant-based system. For example, a regional municipality had the need to monitor the water system such as clean water or wastewater system, also to monitor and control the power distribution system. Similarly, in the oil and gas midstream application, it leveraged the geographically distributed SCADA systems. Protocols such as a DMP3, IEC, and advanced Modbus are prevalent in these industry verticals. Well, AVEVA Premier Communication offering a telemetry server, which is specifically designed to complement supervisory communication portfolio with telemetry specific functionality. So as we say, we have the TMP3, IEC, and Modbus in my telemetry server. Also delivered as a separate software, the tight integration between the telemetry server and system platform allow the user to leverage on the rich portfolio of the software. The MP3, or what they call it, distributed network protocol, is a protocol that was developed to allow for flexible, secure communication between devices such as RTU, IED, SCADA, HMI. The MP3 support many types of communication media, including data radio, leased line, dial-up, Ethernet, fiber optics, and satellites. Now, regarding the configuration, as it's mentioned here, the configuration is totally different server. It's not the OI server. So this is why we will go for a total. We will create a new session for just telemetry server, because here you see we will create the channels, slave, master, the I/O, and there is many options in AVEVA's telemetry server. From the system platform part of view, we have just to follow the syntax and simply connect the attribute to the server. And that will be all for this session. Please, if anyone have a question, Nader, thank you for your attendance.
Thank you, Munzer. Thank you, Munzer, and thank you, Janine. So I'm just waiting to see if anyone has a question. First of all, it was a very comprehensive slide, so thank you again. As we have discussed before, so regarding the telemetry servers, we will have a separate session, right, Munzer, dedicated for the telemetry?
Yes. There will be a dedicated just for telemetry server, because we found that there is a lot of options and configuration that we can do with the telemetry server, and to squeeze it in IoT devices, telemetry server will not take the whole thing. Then it will not be clear. So that's why today we'll give a small briefing. What is a telemetry server? And we have it. What are the drivers that support by telemetry server? But there will be a session deeper that describe everything.
Okay, that's
with
great.
With a demo, with configuration, with an application, with everything.
Okay, sounds good. So again, ladies and gentlemen, it seems no one has a question for the meantime. You can just feel free to send us any of your questions by email, and we'll be sending you the webinar recording with the survey. So filling the survey will help us to even give you better, let's say, webinars topics in the future. So feel free to suggest anything. And thank you again. See you next Thursday. Thank you so much, Munzer. Thank you, everyone.
Thank you, Nadir. Thank you so much. Have a nice day.
Thank you, Nader.